On November 15th, we dissected an earthworm. They have a closed circulatory system and three main blood vessels that supply blood. Those are the aortic arches, dorsal blood vessels, and ventral blood vessels. The circulatory system is responsible for pumping and carrying blood throughout the earthworm's body in order to survive. General adaptations in earthworms are that they cannot see or hear, but have become very sensitive to vibrations. They can feel the vibrations of a predator in order to survive and escape. Earthworms have a streamlined body structure to help it move through narrow spaces in the soil. Earthworms are trained to migrate or move throughout the soil to wetter areas in the soil when the skin of the worm becomes dry, so that it does not dry out. Other adaptations in the worm, specifically those for the circulatory system, are that the earthworms have circulatory muscles that surround each body segment. They also have longitudinal muscles that run the length of its body. These two groups of muscles work together to help make the earthworm stronger. The worm has 5 hearts that beat together. The worm that we dissected had 5 hearts like any other earthworm in order to keep blood pumping throughout its body. An earthworm must be wet or else it will suffocate. This is because of dry skin, which prevents the diffusion of oxygen through the worm. In this picture you can see these black organs. Those are the hearts. The earthworm's niche. Earthworms break down and decompose organic material. They can be found around the world anywhere that has warm, moist soil. They feed on dead plant material. They put nutrients, nitrogen and phosphorus, back into the soil, and they are eaten by predators including birds, rodents, snakes, and frogs, insects, and more. They are essential to good soil.
So next up is the frog. The heart of a frog is dark in color and is located near the ventrally, which means basically in the abdomen. The only chambered heart that we saw in all our specimens, which means it has 3 parts. The 3 part is the left and right atrium, the 2 atriums, and the ventricle. Blood from the lungs, which has oxygen, and blood from the body, which doesn't have oxygen, go into the atrium, mix, and then are pumped out to the rest of the body. So as far as frogs' general adaptations, they have powerful back legs that let them launch themselves up to 20 times their body length, and small front legs that are specifically designed to absorb the shock of landing after these great heights. Frogs have webbed feet that allow them to swim easily, like, flippers on humans. Frogs have eyes and nose that are high on their head, so that when they're swimming on the surface of the water, the only thing that needs to be out of the air or out in the air are their eyes and nose. So in their early stages, they have gills. Those are the tadpoles, and they swim in water. But as they grow into frogs, the gills disappear and are replaced with lungs in order to help them breathe on land. So as far as the circulatory adaptations go, frogs are cold-blooded.